Hi guys, this is a walkthrough of Dijkstra algorithm based on an undirected graph. This problem is extracted from this video, which I will link it in the description below. Let's start. So, as well known, Dijkstra algorithm, its main purpose is to find the lowest cost path available to find the lowest cost path from a source to destination. So we have a table, vertices, visited, distance from source, previous vertex. So we list down all the vertices that we have. So since we have vertex 8, we will include one more row here. Okay, and then by default, we will mark every single node to be as unvisited, and the distance is infinity. Okay, and for here, it will be blank because that will be filled up when we traverse. Okay, so first, vertex 0. Okay, when we are at vertex 0, our distance from ourselves is 0. So there's the only option of the unvisited with the smallest distance, which is ourselves, so we will mark that as visited. 0 could travel to 1 and travel to 7. So before we mark anything, the second node to be visited or anything, we just note down the distance. So previous vertex 0 to vertex 1, we will have distance 4. 0 to vertex 7, we will have, 0 to vertex 7, we will have distance 8. Okay, so once we fill that, we will check which one has the lowest possible distance vertex. So we will pick vertex 1 because it is unvisited and it has the lowest distance from source. 4 is lower than 8, so we will pick 1. And once we pick 1, we will mark it as visited. Okay, and then when we mark it as visited, we will try to explore again. Now, there's two paths we could go. We could travel from 1 to 2 or 1 to 7. Again, before we decide, we will write down the stuff here. So remember, 0 to 2, we need to take into account from 0 as well. So 4 plus 8 is 12. So our previous vertex here is 1, distance from source is 12. Okay? And we could also traverse through 0, 1, because we are from 1, right? 1 to 7 as well. 1 to 7, it will take a cost of 15, right? 15. So let's check 7. If we put our previous vertex as 1 and distance of cost of 15, we shouldn't do that because we want the shorter distance. So we just ignore it, okay? So this is the updated table, okay? Now, from this unvisited one, we will check which one has the shorter distance. Vertex 7, because it's 8 and it's unvisited. Because we won't pick 12 because it's the distance is bigger. So from 7, we will look at 7 here, okay? Now, since we look at 7, we will mark it as visited because we already decided that it has a shorter distance from source. Okay, 7. Now, 7, I have 3 ways to go. I could go 1, 8, and 6. But 1 is already visited, so we're not looking at that. 7 to 8 will cost me 15 because 8 plus 7. So 7 to 8. 15. Now, the second one, 7 to 6, will cost me 9 because 0, 7, 6. 7 to 6, 9. And our previous vertex is 7. Okay? Alright, seems like it. Okay. So now we repeat the step. We'll check the unvisited ones and see which one has the lowest distance. Okay? Well, the only thing I can see is 6. So we'll mark 6 as visited. So we'll put here 6 visited. Okay. Now from 6. 6, I could only go to 8, node 8, or vertex 5. Remember, I am interchanging the words vertex or node. It means the same thing. So 6, I could go 8 or I could go 5. Okay. If I go 8, okay, my distance would be 8 plus 1, 9, 9 plus 6, 15, which is the same as my previous, is the same as the distance from source that we already written down, so we don't update anything. So, or I could go 5, 6 from 6 to 5, which gives me a cost of 8 plus 1, 9, 9 plus 2, 11. So, to 5, it will cost me 11. And then my previous vertex is 6, because I'm from here, right? Remember, I'm from here. Okay, now let's check again. From the whole table, for the unvisited ones, which has the smallest distance from source? See, I have 12, 11, and 15. So naturally, we will select 15. Sorry, naturally, we will select 11. Which one has the smallest distance that's unvisited? Naturally, we will select vertex 5. So we'll go here, vertex 5. Okay, once we select it, make sure to mark it. We select vertex 5 because it has the smallest distance from source for the unvisited ones. So after we go to vertex 5, there are 3 possible paths of way we could explore. Vertex 2, vertex 3, vertex 4. Okay, now, if I go vertex 2, meaning that 11, my previous one, 11 plus 4, it will be 15, right? 15 is greater than the distance from the original distance from source 1. So I do not update it. Like, I don't want it because it's greater than that. So I just don't do anything. Well, if I go to discover node 3, I will get, so since I already have 11, right? 11 plus 14, it will be 25. So it will be 25. So we'll put here 25. And then our previous vertex is 5. And then again from 5, I could go to 4. My previous is 11. If I go to 4, meaning it will be 11 plus 10, 21. And then my previous vertex is 5. Okay? Now again, among all of the unvisited ones, which one has the lowest distance from source? It is vertex 2, right? So we'll mark that down as visited. Now from 2, we could explore 3 and we could explore only 3. Why? Or 8. Because 2 to 5, 5 is already visited, so we ignore it. So 2 to 3, we could have a distance of, you see, we have 12 already, right? So 2 to 3 will be 12 plus 7, which is 19, which is smaller than 25. So we will update it to 19. And then our previous vertex is 2. And then from 2 to 8, 2 to 8, okay? 2 is already 12. To 8, we have an additional of 2, so it'll be 14, right? But let's check. 14 is smaller than 15, so we will update it. And our previous vertex is 2. And then we will mark it as, okay, before we mark, let's check. Which has the smallest distance from source and is unvisited? It's vertex 8. So we will mark it as visited. So from vertex 8, and now we're left with 3 and 4 here. The smallest distance from source is 3 here. So since 3, I can only visit 4 because the rest of it is visited. So 3 to 4 is the, originally I have 19, right? 19 plus 9 is 28. 28 is greater than 21, so I'm not going to update it. So I will remain this, and then I will mark it. And then the rest of it, I will mark it as well, 4. So now let's track back our path if we pick vertex 4 as our final destination. So from vertex 4, our previous vertex is 5. Then we go to 5 again. Our previous vertex is 6. Then we go to 6 again. Our previous vertex is 7. Then we go to 7. Our previous vertex is 0, which is the source. And then you reverse it. You'll get 0, 7, 6, 5, 4. This is your shortest path from the source 0 to the destination, vertex 4. Am I correct? Yes, I'm correct. I already prepared an answer. So I hope this clears any confusion. If you're not sure, you can feel free to leave a comment down, or you could look at the original YouTube video, provided that you understand Chinese, because it's explained in Chinese. So again, Dijkstra's algorithm is used to find the lowest cost path from a single source node to all the other nodes in the graph, as long as all the edge weights are non-negative. So remember, once you track back, you have to reverse because you're starting from the source here. And this does not only work for vertex 4, it also works for any destination that you want to pick, like vertex 8, vertex 3, and so on. Okay? So I hope this helps. Not sure if I'm gonna post any CS topics related videos in the future, but thanks so much for watching. Bye.